All right, why don't we get started? Thank you everyone for joining. It's our first meeting as a Linux Foundation project, and we thought it would be a good topic for us to discuss and share more about why we made that change and what that means for the project, and just have a Q&A. So we're gonna get started with that. After that, we have a talk from Carter, who's on the line from Gusto, and Shanshan as well, and they're going to talk about Tableau integration. And after that, we have folks from Square, Josh and others, who are talking about Gremlin proxy design. So pretty excited for today, and thank you for joining. And we'll kick it off with Tao and I talking about the Amundsen donation and why we did that. So let me start sharing my screen here. Feel free to type in your questions on chat at any time. Can you all see the screen here? Okay, I assume silence is a yes. Cool, so what we're presenting here is work that was done by the Amundsen team at Lyft, and Tao and I are just presenting that here, but there's a whole bunch of people, Marcos, Tamika, and Shengu, and the rest of the Amundsen engineering team.
Hey, Mark, I didn't see your slide, or just me.
Oh, really? Okay. Let me...
We see your screen, but not your slides.
Perfect, thank you. Is this good?
Yeah.
Okay. Cool. So the first thing we want to talk about, like, why donate Amundsen? Amundsen has been started on Lyft's GitHub page, and we wanted it to be in a neutral holding ground where we can have a larger community of contributors contributing to the project, and that helps us in growing the community of people who are contributing to the project as well as people who are using the project. And most importantly, we wanted to adopt a governance model where it wasn't just one company or one organization that was the only company driving the project, right? The project has now over 750 people in the community. We have over 20 companies using it in production. We felt like it was very important at this stage in the project for it to be a community project in the true sense. And that was one of the main reasons behind donating Amundsen. And the second thing we wanted to share with you is our choice of the foundation. So many of us actually are committers in the Apache Software Foundation, and it is a pretty interesting decision about why we didn't choose an Apache Software Foundation to donate the project versus Linux Foundation. And I think this was a hard decision, and there's no right or wrong answer. It's mostly comes down to preference. But the TLDR here is that ASF has a release process historically that's very time-consuming, which would have been not great for our multi-repo setup that we have currently in Amundsen. ASF also has strict guidance on using processes, so communicating via email, having a certain amount of time between cutting out a release and actually pushing it for voting. An incubation period for projects can take anywhere from 1 to 5 years. We felt for a project that's relatively new like Amundsen, has a community that's already working pretty well on Slack and is pretty agile in its release process, that we wanted to explore to see what other options are available. And the very first option we explored was Linux Foundation, and specifically under Linux Foundation, there's a sub-foundation called AI, and which has data and AI projects. And that's the foundation we ended up choosing. So it's Linux Foundation, as you know, is where Linux was developed, and it's one of the largest open source foundations. In general, it's more flexible. So you can bring your own governance model. They have a standard suggested one for you, but you can tweak it in whichever way you want. And same applies to many of the processes, right? They're more flexible and less rigid around thou shall follow this process. And that was one of the driving factors for us to consider this foundation. We also saw that there are a lot of other projects in the data ecosystem, like Delta Lake, and obviously other projects outside of the data ecosystem, like Kubernetes and Envoy, that are part of Linux Foundation, which ultimately ended up pushing us to decide towards that. If you have any questions in the meanwhile, feel free to ask them on chat, and we'll take them towards the end of the presentation. And then I'm going to pass it on to Tao to talk about the next few topics here.
Sure. Thanks, Mark. So what does it mean for the community? First, we now have an open governance model. As Mark mentions, Linux Foundation is pretty free and flexible for you to bring your own governance. So when we consider our governance model before entering the incubations, we take into consideration mostly from Envoy, which is a popular open source project in CNCF under Linux Foundation, originated from Lyft, also ASF. So for me, for example, like me and Bokeh, like also a key contributor for this project are from Apache Airflow, PMC. So we both of us like the ASF model a lot. So when we building out this governance, we take both into considerations and building out a transparent process on how to operate this model. So in the end, after several discussion between like internally Mark, Tamikas, and Marcos, me, and a few others, so we ended up at this governance model, and we create documents for this software in the GitHub repos under Amundsen. Second is we now build a process to introduce new maintainers. As mentioned, like the project initially started at Lyft, and a lot of people, for example, are a contributor from Lyft. So now this project has been growing into a stage like many people are contributing, and we don't have enough resource to facilitate all the discussions. So it will be good if like we have a process to introduce the maintenance. So we end up like have owners of all the initial contributors, and I could share more light on how we choose this one. So at Lyft, when we started this project, there are many people, many people has been contributed to these projects. At Lyft, is we are not really tied to a single project. We shuffle around doing contributions based on priority. For example, for me, I have been involved in Airflow's ETL, Amundsen, and even like internally some initiative like CORS, GDPR, etc. And thus the project has been contributed by many people, and then they shuffle around and work on other things. So in the end, that many people has been contributed, but and some could be like co-contributors, some could be product manager. For example, like even like product manager, we have 3 product managers like Mark, Philip, and Daniels. So they all bring value. But in the end, when we look at the list, we consider mostly the criteria is like active and consistent contribution, both for code and non-code. So for example, we also non-code is we want to make the project more diversified. And we also want to include a lot of people that is maintain a core component, for example, like Apache Atlas integrations, who could help to maintain and drive the discussion and roadmap for these components. So that's why we reach this initial list. And having said that, we know like this project has been loved and contributed by many people, and a lot of people, and in many different ways. And you will feel like you should be included, and unfortunately we didn't. I would say a bit sorry, but we now have a good establish a good process and clear guideline how to introduce new peoples and as a new maintainer. And if you love this project, I would love to contribute and become a maintainers, talk to us, and then after we we would love to include you after like we work together for several iterations. And the clear guideline we document in the governance model as well. So feel free to ping me or others are Mark if you have any questions. So lastly is like we also improve the community channels. Like for example, after we enter the LFAI, we also have a new mailing list. So for those who are very join this project in the inception, we actually have a mailing list we never use. Now we have another mailing list again. Hopefully we could use this time. And also we may plan to move to other more meetings like Zoom instead of Hangout, but that is TBD at this moment. So next slide. So how you could help. So having said that, we we start the initial governance model, but you could still keep evolving and improving. So what you could help is that you could help to review this governance doc and give us feedback. And if you see anything to improve, let us know. We also like add a roadmap proposal process. Like Feng's Marcos, he just created a folder or repo for IFC. So traditionally, where we have some features, we just create GitHub issue in the Amundsen projects, and it's sometimes buried across many other different issues. So now if we create separate repos dedicated for this IFC, and what considered should need the IFC or not, we also document in the governance doc. So feel free to take a look and let us know any feedback. And then contribute, how you could contribute. So first, of course, is you could help to contribute any from small to big, like bug fix, features, anything. Also like process, like help to like review PR, help to answer questions in Slack, help to facilitate discussions, help to drive initiatives. Also share your work in the communities, and also like spread the word. It's like Amundsen, although it has been used and not by many people, but it's still a pretty new project, I would say. So share the information across your channels and let them know like there's a Amundsen project exists. Write some blog posts if you are using it and have some experience on that. Maybe even give talks in the industry about your experience. So next step, from a community perspective, so one of the pain points is the release management. So for those know, so Amundsen is a multi-repos. There are stream service repo and two library repos. They all release differently. So one of the things we want to do is like we improve the release process, better document the change log about all the features are included. I know we do that in the front end repo. Let's say we include which libraries and what versions and what's the features. Thanks, Tamika, for all the hard work. And we still want to say all the other repo. We also want to document those. So one of the potential solution, given the complexity of we having multiple repo, is like we have each PR feature, we have a issue associated, and when we attach like a milestone, I saw some other projects doing so. Is like attach a given milestone, and we after a regular cadence, for example, 1 month or by 2 months, we do a release in the central repo across, and then document, have a clear change log saying what are the features, include all the different repos versions, and then update Docker file, make sure the Docker file is up to date. And then second thing is improve the roadmap management. Like for example, we now create a RFC process to document everyone's their feature requests. And lastly is improve the documentation. We know like just have the code is doesn't give much help. Is the document actually is the key criteria for people and community to use the things. We want to improve this part, and if you think anything is that could help process. Thank you. Any questions?
All right. Yeah, questions. We have a few minutes if you folks have any questions. We got a question from Carter. How long will Amundsen be in incubation? So the Linux Foundation usually says it's about 6 to 18 months, but it is not guaranteed. It depends on project to project and you meeting certain criteria. And the criteria is mostly around having an inclusive community. Yeah. Other questions, Tots?
So there are, I could add some more. So it's I look at the LFAI when I did some investigations. It's like there are 1 or 2 already graduate. They have certain guideline. Normally it takes like one years to 1.5 years, I would say.
Cool. Let's wrap this topic up. I just wanted to say this is going to be an ongoing conversation, so we can continue more thoughts and topics on Slack as well. But without further ado, I wanted to pass it on to Carter to talk about Carter and Shanshan to talk about Tableau integration at Gusto.
All right, awesome. Thanks, Mark. Can everybody hear me okay?
Yep.
Cool. I'm going to go ahead and present. Sorry, I got to figure out which screen it wants. We'll do this one. Okay. All right. All right, can everybody see my screen okay?
Yes.
Awesome. All right, so hi, everybody. My name is Carter Landis. I'm a data platform intern with Gusto this summer. And we're going to be today, myself and Shanshan will both be talking about the Tableau dashboard integration that we built. So first thing we're going to do is I'm going to actually pass it right off to Shanshan, and she's going to talk a little bit about the context behind the integration and a little bit about what Gusto is if you haven't heard of us before.
Cool. Thanks a lot, Carter. Hi, everyone. My name is Shanshan Wu, and I am the product manager of our data platform team at Gusto. So for those who don't really know about us, Gusto is a people platform team company that we're mostly provide services like payroll, HR, benefits, and whatnot to small business. We were founded a couple of years ago, so as a very fast-growing company, we definitely depend a lot on data to make and adjust our business decisions. But at the same time, we have also experienced the so-called growth pain, that the lack of up-to-date data documentation forces analysts to spend way more time than they should during the data discovery phase rather than actually running the analytics. That is why we just decided to embrace Amundsen to switch from the mode of giving people the fish to teaching people how to fish in the ocean of data. And Amundsen is a key and also the guide to do it, so that we can turn the tribal knowledge, which has been passed by words, into something that it's documentable and shareable in the form of an application. We launched the initial version internally about maybe 2 months ago, and we've got super positive feedback from the users, but still there are questions. One of the main areas that people are facing is we utilize Tableau, which is a very industry standard, a BI tool as a single source of truth when it comes down to things like standard and the corp level dashboards and reporting. But the cliche questions that people usually have are things like, which tables are used to create the corp level dashboards in Tableau and a report in Tableau? And is there any existing dashboard or analytics that I can just reuse, or maybe just make some tweaks to meet my needs? Since we didn't have any lineage or linkage between the data tables and the Tableau dashboards managed anywhere at all, it has been very difficult to find the answers to those questions until our users start to talk with our BI team, biz team, or sometimes even engineering teams, or willing to spend additional hours reading through the very complex SQL code, which is definitely a lot of fun, right? So this does not only just reduce the reusability of our existing analytics and dashboards, but also create all the unnecessary work for the data users that still decreases the overall productivities. So once we learned that Lyft has been working on the integration with Mode, and Asana is doing the similar thing with the Redash, we just decided to give it a try with Tableau. We do believe Amundsen is the ideal platform to service the lineage between datasets and Tableau dashboards and make another big step forward to turn it into the one-stop shop of the answers to any question our users could have about data. With that being said, I'm actually going to turn this over back to Carter to look at the fun stuff under the hood. Thanks, Carter.
All right, thanks so much. Yep, thanks so much, Shanshan. All right, so we're going to get into the technical overview of the extractor. We'll cover how Tableau fits the data model, as well as some architecture choices we made. I'll do a live demo and talk about some challenges, and then some thoughts moving forward. And Mark, feel free to interrupt me if when we get a little bit close to time. I want to make sure that we still have some time for Q&A at the end.
Sounds good, man.
All right, so we just briefly talked about this, but I thought I'd give a little bit more of an overview of what is Tableau if you haven't heard of it before. So Tableau is a data visualization and analysis tool that allows anybody to create really extensible and powerful reports and visualizations. It's widely used across many industries, primarily for business intelligence and reporting purposes, like Shanshan mentioned. At Gusto, it's used primarily by our BI team, but it's used across the entire organization. And the general hierarchy of how a dashboard or a workbook is called is there are top-level projects which store a collection of workbooks. The workbooks are the core unit, if you will, and we'll get a little bit more into how that fits into the data model in just a second. And then within each workbook, you can have a variety of views, like the ones you see here. You can also have charts and sheets that are just data, and you combine those together to create things like this. And this is not a Gusto dashboard. This is just a sample one that I found. But we will look at some other ones later. So I want to start off by talking about the data model. So Tableau maps pretty simply into Amundsen. There's not a whole lot of stuff that's weird, but there are some things that don't exactly work. Over here on the left, you'll see what maps correctly. So we have top-level Tableau project is the dashboard group, and the actual workbook themselves are what we use as the dashboards. We briefly toyed with the idea of having individual, like what you might think is more of a dashboard, like a single visualization map as a dashboard, but broke some of the other assumptions we wanted to make, and we felt this was overall a cleaner abstraction. Each of the views within a Tableau workbook corresponds to dashboard charts. We'll talk more about that in a little bit. And then the custom SQL queries that you can use to build some of these charts and these workbooks are what map to dashboard queries. However, there are some things that don't exactly map over. For example, Tableau doesn't really have any concept of executions in the sense that Amundsen does. It's just mostly whoever updated it last is the closest thing. So there's not really a good solution there. There's also not a relationship between what are called views. So when I say views, I'm referring to the sub, that what you might think is a regular dashboard, kind of like I said earlier, the individual, like this one graph or this one visualization. There's no relationship between those and queries in Tableau. You can have queries that are just used to build data, and you can also build charts and views and such without using a query. You can link it directly to a data connection. So that doesn't really fit into the Amundsen model of, every dashboard has charts and every chart is built from a query. And then additionally, usage within Tableau is tracked at the individual view level and not at the workbook level. And again, we'll get into both of those in a little bit more detail a little bit later on in the presentation. When it comes to actually getting the data out of Tableau, there were a couple of choices. So the first one was the REST API. The REST API is available on all Tableau sites and exposes quite a few endpoints, but very little metadata. It's mostly CRUD operations and updating and working with the resources in Tableau, and is primarily designed to allow developers to build extensions and additional plugins. However, there is a metadata API. It's also available on all Tableau sites, but must be manually enabled by a Tableau administrator. And what's really nice about this is it actually uses a GraphQL schema, which made building the integration, going straight from the metadata API into Neo4j really, really easy. It's got a lot of metadata, but it doesn't have all of the metadata you would expect about every resource. There's some things, for example, you can't get project descriptions really. And there's some other things that you would think you'd be able to get that are not there. It also has some weird behavior. Again, we'll touch more on that later. And then the third one is an internal Postgres database. I don't think this is necessarily available to every Tableau user or Tableau installation. I think it's kind of dependent on whether or not you have access to it or if you're running your own hosted Tableau server instance. It's also, in terms of what we did for the integration, the biggest unknown. The metadata API serves most of the needs. And so when we were building the integration, we decided that this might be something we go back to later if we absolutely can't get some data from the other two APIs. But this is one of the things that we might come back to later. So a bit of the important architecture bits. It uses a personal access token for authentication with Tableau. Pretty easy to create once you set the, and then you just have to add those credentials when you build out the config for the extractors. It follows a one-to-one extractor to model convention, similar to how Mode does, or how the Mode integration is built. And all the extractors use the metadata API. For now, at least. That actually might change because some of the data that we want is only available through the REST API, but that's a later problem. Filtering by project is supported, and it's filtering only by top-level project. So if you have an outer project and then an inner project, the metadata API thinks it only sees that inner project. So, and this is also by exclusion. So you just specify the projects that you don't want to include, and it assumes you want everything else. And then permissions are actually supported by the metadata API. You can also obfuscate the results if that have sensitive data, or check that the query or the results you're getting actually the user you're making the request as is allowed to see those. But currently the extractor doesn't really deal with that. It just assumes that you have permission to see everything. That's something we could revisit later, but for our purposes, we didn't feel it was super critical for the first pass. These are the included extractors. So there's a dashboard and query extractor, which function pretty much how you think. There's also a table extractor, which builds the relationships between pre-existing dashboard entities and table entities. And there's also a last modified extractor that will get the time of last update for every extractor. One thing that I did want to call out that's not actually on the slide is, and we'll talk more about this after the demo, is we did build an external table extractor. So one of the things that makes Tableau really powerful is that you can have additional connections to things like Google Sheets or CSV files. You can connect to Salesforce and all these other things and pull in data directly from that. The way that Tableau presents those in the metadata API is a little bit different than it presents what you might think of as a regular table entity. And there are some weird things associated with that. So we built out a pretty primitive version of the external table extractor. We weren't exactly sure if it's something that others would want, given that the way that you connect to these is often pretty specific, and there's some weird behavior that happens, something we would love some feedback on, and I'll talk more about it later. But I did also want to call that out. But these are the four main ones. All right. So now we're going to switch to doing a little live demo. So over here, everybody still seeing my screen okay? Does Tableau show up for you?
Yep.
Cool. So the first thing I'm going to do is I'm going to navigate into this folder. And let's say I want to look at one of these dashboards. We'll pick churn analysis. I'm not actually going to click into it because I don't want to show off all of our Tableau data. But these are a variety of views that exist within this workbook, as well as you can see some additional data, some data source connections. So if I'm a new Tableau user and I don't really know what any of this means, Amundsen is the perfect tool for me to find more context. So what I'm going to do now is go over to my local Amundsen installation and search for this dashboard. Oops. There we go. So this one here is the one I want. And then, I assume most of you have seen something that looks kind of like this before. We have some information about when it was created and updated. Again, there's no execution, so this isn't, these aren't populated, but we can see that, in fact, we can look at the queries. And this is actually something that I also wanted to highlight. In Tableau, in the web version of the UI, you actually can't look at queries. You can't edit them. You can't rename them. You can't look at their text. If you want to look at the contents of a query, you actually have to download the workbook locally and open it in Tableau Desktop. Not everybody has access to do that, or at least not at Gusto. So this was a really cool feature that Amundsen provided that lets even our power users who want to quickly check the contents of a query to see if it's the one they're looking for, they can just come to Amundsen without having to worry about downloading the workbook and going through all that rigmarole. And then over here, we can also see that, of course, we've got some tables mapped coming from our Redshift cluster. We can click into this and look at some other, this is, of course, the tables, and then all the other dashboards that use this table. We'll go ahead and pick this one. And then, of course, we've got some more tables and some more queries. And then we can open this dashboard back up in Tableau. Pretty simple stuff. Kind of works how you would expect a dashboard integration to work. But first time I got that all working, it was super awesome. It was really easy. Actually, I was able to get something working after only 2 or 3 days of doing we had an internal hackathon, and it only took me 2 or 3 days to like kind of get a very minimal MVP. So kudos to the Lyft team for making it super easy to extend. All right, we'll get back to the presentation. So now I want to talk a little bit about some of the challenges that we did face while building this integration. And I mentioned a couple of these, but I'll talk a little bit more about them now. So the first one, like I mentioned, queries are not exposed in the web version of Tableau. The Amundsen data model assumes that you can link to a query by giving it a URL and then open that query up directly in whatever product you're using. There is no real workaround for this. Queries simply aren't viewable really in any form on the online version of Tableau, and there's not sure of a way to automate the process of downloading that workbook and then opening it up. So right now, the query extractor just leaves that URL blank, and when you click on the button to go navigate to it, it doesn't really do anything. The next problem is that there is no relationship between views and queries in Tableau. So views can be built straight from that Tableau data source, like I mentioned, or using a query, but it's not strictly necessary. One potential workaround could be to create a no-op chart for each dashboard that just holds the queries. And then another solution would be to get rid of perhaps that abstraction of dashboard chart or dashboard query chart. Sorry, other way around. But that depends kind of on how chart data is going to be presented in the front end when it's there, as well as if we want to break that assumption for other products. So this is kind of an ongoing question. How do we solve this issue? Another one that we ran into a lot is actually the data returned by the Tableau metadata API is sometimes different than what you would expect. And there are a couple examples I have here. So the first one is there's this weird problem where sometimes tables returned will have two schemas. In that the schema value will be some like fake schema value that doesn't really exist or isn't correct. And then the table value will be, it'll be the actual schema and then the dot and then the table name. So Tableau, something weird happens in the back end. We aren't really sure why, but you have this, what looks like a 3-part table name that's not correct. In every case so far, we figured out that you can just ignore the fake schema, but that's something that remains to be seen if that's always true or not. Additionally, some of the custom SQL query names don't return. The name is different in the metadata API than it is when you look at it in the Tableau UI. Like in the Tableau UI, they all have actual names that describe what they are, but for some reason, a lot of them return as just the phrase, or the name is just the string custom SQL query. We haven't figured out why this happens, and it makes the queries a little bit less usable in the sense that you can't quickly skim through the names and try to find the one you're looking for. You have to actually click in. Again, we don't really have a workaround for this right now, but it's something we want to continue to explore. And then the same thing happens with external table names. Some of them just have weird names that have a bunch of weird characters, especially if they come from things like Google Sheets. We're not exactly sure why that happens, and it seems to be specific to the metadata API. Again, that's something we want to do some more digging with, but it creates some challenges when trying to figure out, is this resource the one that I actually want? And the next one, and this is kind of more of one that was specific to us, is that when we were talking with our BI team and scoping this integration, they made it clear that to them, the workbook owners are much more ephemeral in Tableau, and they're not exactly indicative of what you would think. It's, from my understanding, pretty much the last person who updated the workbook is classified as the new owner. And more often than not, if we were to expose that information in Amundsen, it would make it a bit difficult to actually find out who the real owner is, and most of the time would just cause confusion because, this says this person updated it last, but they didn't, they just made a minor tweak, and the person who actually built the whole thing is somebody else. And so for that, we just didn't worry about populating that owner field. It wouldn't be hard to add this to the extractor. It's just not something that we did right away. And then finally, Tableau only counts usage statistics for views. So to get dashboard usage counts, we would have to aggregate the statistics for all of its subviews. This data is also only available through the REST API, so that adds a little bit of complexity, and we'd have to make calls to the REST API in the middle of doing an extraction. It wouldn't be super challenging, I don't think, but it's something that we decided we didn't want to tackle right now, especially since it was going to require some additional logic to actually get those usage counts. All right, and then talking about some wrapping up stuff, some next steps. So immediately coming up from us is we'll be finalizing the first version of our PR back upstream that includes all the stuff that I've talked about today. My last day is actually this Friday, so after I leave, Alex Levine, who's also on the call, I believe, will be taking over as point for me as far as the integration goes. We'll also be working with Dorian Johnson to any changes that come from the MyPy typing PR that he's been working on. We'll need to integrate those as well, but that should be pretty simple. And then there are a couple unit tests that we need to finish to make sure that the coverage is up to snuff. Some things that need further research, at least on our end, or just kind of open questions as well. Doing those usage calculations and exactly literally the calculation for doing that. I haven't looked at exactly the structure of the data that gets returned, so I'm not exactly sure what that looks like. Dashboard previews are also available through the Tableau REST API, but that's not something we decided was super critical for the MVP, so we didn't worry about it. Again, getting to the root of that undefined metadata API behavior, which might there might be some correlation with or communication with Tableau that might need to happen there to see if they can help us figure out why some of this stuff is happening, as well as looking into supporting permissions on the extractor side and making sure that that stuff works okay. Some questions for the community at large. We didn't build a user extractor because we didn't think it was super mission critical for this. It would just be adding a Tableau user ID. It wouldn't be adding a whole lot of functionality, so we didn't focus on it. And for the same reason, we didn't build a chart extractor either. Well, primarily because the data is not surfaced in the front end right now, so we weren't super worried about it. But also for that same reason of how do we deal with this, the difference in the abstraction of the data model between Tableau and Amundsen. So that's kind of an open question. Another question would be, would it be helpful to have a generic GraphQL extractor? We built one specifically for Tableau, but it probably could be easily reworked to be more generic, kind of how the REST API extractor has been made more generic, and that way it can be used elsewhere. And then just thoughts on the external table extractor, and there's some other stuff related to that that I won't go into too much detail here. But these are just, if you have feelings about these, if you want us to work on those, we would love your input. And then last thing is just a couple of really quick suggestions, nothing super huge. I know this has been talked about before, but doing the visibility flags for front-end fields that have no meaning, specifically for Tableau, because it has no context of executions, it would be nice to have that hidden on the front end. Of course, I realize that sometimes there's a difference between having no value and having no meaning. So it's kind of a give and take there. And of course, if there are multiple dashboard types, that adds some complexity. This is also kind of a nice to have. We've got some downstream changes, some other downstream changes that we have made at Gusto. So that could be something that we just do on our own. And then I know that John also talked about this when he did, talking about his Redash integration. But I think that supporting a direct table to query relationship might help alleviate that problem of dashboards charging queries. And it would also, I think, open up some cool ways to explore the data that we can't currently do. And that is pretty much it for my presentation. I don't know how much time we've got, Mark, but I'd love to do some Q&A if anybody's got some.
Sure. Thanks, Carter. Questions?
Hey, Carter, can you hear me?
Yep.
So one question is like, so in your extractor, right, when you're using the metadata API, would it get all the projects and all the workbooks, or you have to specify some specific projects or workbooks which you're interested in? I mean, if I don't know any information, will it scrape through and get everything?
So if you don't tell it that you can support filtering for specific, it's by project only. And you just specify the ones that you don't want to include. So it assumes you want everything except for the deny list that you give it. And you give it just a list of the names of those projects. And it will check each workbook to say, okay, does this workbook belong to this project? Yes, it does. Okay, I'm just going to ignore it. And so you can filter by project only.
So Carter, you're saying there's an exclude list. Is there an include list also, or can both be empty?
There is not an include list. The way that I just picked to do an exclude list. It might make more sense to do an include list if there's, we just want these couple folders as the source of truth, and everything else we just want to ignore until we know that we want it in Amundsen. I could totally see that use case, and it would not be very hard to switch that, or even to have some combination of both. But right now, it's only exclude.
I see. Okay, cool. And were there any timeouts if you don't have any exclude list? If it is taking too much time, was there any timing out issues with the API because too much data to get it?
So that is something that we thought about. So Tableau API tokens. So you have to authenticate with the Tableau API using your personal access token. It then gives you a request token back that you use on every subsequent request. And that request is good. That token is good for 2.5 hours, I believe. So it's good for a while. And the nice thing is each extractor gets its own token when it runs. And because it's GraphQL, we can get all of the data back in a single request. So there's a very low chance that retrieving the data is going to take more than that 2.5 hours, or for some reason, so that token would expire. And I've noticed that it's usually pretty snappy. Like, it usually doesn't take me more than a second or two to get all that data, even if I am looking for a lot of relationships.
Awesome.
That could just be due to the size of Gusto's, how much Gusto uses Tableau. But I would be shocked if there was a case that it took 2.5 hours to get all of the data back, if that answers your question.
Okay.
Thanks,
Carter.
Carter.
So that means that it's very stable API. So that's good to know. Thank you.
Yep.
Thanks again. We have one more talk, so I'm going to invite Josh from Square to come and speak. Thanks again, Carter. If you have more questions for Carter, please ask him on Slack.
Yep. Thanks, guys.
Hello. Just pulling up my slides here. All right. This should be sharing. Y'all see this okay? Just pulling up. Cool. So I'm going to talk about Gremlin for Amundsen. So give a quick introduction to what Gremlin is, then a quick overview of our Amundsen Gremlin. I'll talk about some lessons learned, and then the upstreaming plan. So without further ado, let's jump into the Gremlin introduction. So Gremlin is like Cypher for Neo4j. It's another graph traversal language. It's part of the Apache Tinkerpop graph computing framework. Like one bit of nomenclature, like Gremlin uses vertex and edges, Neo4j uses nodes and relationships, same thing, different name. Sorry, I have a co-presenter trying to help out here. We have wide support amongst different databases as well. Like Neo4j can support Gremlin as well, like Hadoop, Janus Graph, AWS Neptune. So like in theory, you can have a lot of different database backends using Gremlin. So what does Gremlin look like? Here are a couple like very simple queries. Like g.v has label airport. That's basically looking for an airport vertex with the code DFW. Cypher equivalent over there. It's a little bit more verbose, but it lets you do like more powerful traversals. You can specify how you want to traverse the graph. There's also like the outie NV. So like outie is like outgoing edges. NV is like the vertexes pointed at by those edges. And if you want to know more about Gremlin, I would highly recommend Kelvin Lawrence's free book, Practical Gremlin. It's really great. There's a lot of detail. It'll tell you more than you could ever possibly want to know about Gremlin, probably. And if not, you can send a pull request. And, add some months and Gremlin implementation. So like, first off, why did we build this, right? I mean, we have the Neo4j graph proxy. Like maybe that's fine. Except we're not a data infrastructure team. We're like the privacy engineering team, and we have limited support for Neo4j within Square. And like the self-hosting Neo4j was kind of an operational burden for us. Additionally, like Neo4j online backup capability requires the commercial licensing. And for our purposes, the pay-per-use cloud database is much more cost-effective. And another thing is like, in theory, this is very platform agnostic. We could use this Gremlin proxy across multiple different graph database platforms. In practice, this tended not to be true because of some changes we had to make on the write side to get like performance writes. But it is still true for the get side proxy codes. Like it's basically halfway there if you want to use Gremlin for a different graph platform. So what does this look like? So here's the Amundsen structure you know and love. Data builder feeds metadata and search services with a front end on top. We have this additional Gremlin shared code here. It contains some like shared Gremlin infrastructure. Some of this is generally useful, like we convert classes into just like strings for Gremlin traversal, and you know that's generally broadly useful. But some is very Neptune specific, like to the bulk loader, which is one of the many ways you can load your data into the AWS Neptune. So the proxy itself is a metadata store. The read end is basically what you'd expect. It's similar to the Neo4j. You just have fairly straightforward Gremlin queries. We have some light write endpoints for things like description, tags, etc. So this part should all be broadly applicable to any database that uses Gremlin. There are some slight differences, of course, in connecting to the database, like what formats your date time strings end up in, but it should be pretty useful for anyone else who wants to work on Gremlin, even outside of AWS Neptune. Also, as part of this work upstream, we'll also be working on upstreaming the abstract proxy tests, which is like a unit test we added for the metadata service. So the theory is you construct one test case, you can test it against all the proxies. So we've done heavy development on our metadata service, and this was super useful to prevent from breaking the Neo4j, running on Neo4j, and now Gremlin, now that we're using the Neptune. So we have these running in CI, and so in the ideal world, we get these running in Neo4j and Amundsen CI as well. And maybe if we have a few contributors to the Gremlin side, we could spin up a Gremlin instance for the committee. You could run some simple tests for any database. Like for our internal Neo4j, we had some put post table codes in our proxy. But we know y'all use the CSV extractor, so probably your implementation of the Neo4j abstract proxy test is going to be using that as well, in a shared similar setup to what we would do for Gremlin. And here's just a very simple test case. You create a table, you put it, you get it, and you actually round trips to the database, so you can prove that you haven't broken anything, which is very useful if you're making a lot of changes to your metadata store. So data builder, the data builder basically just uses the Gremlin shared code, upload large batches of vertices and edges in Neptune, fairly straightforward. So lessons learned. So those who've been following along in the Slack, when we first talked about Gremlin and AWS Neptune, this was a long time ago. Since then, we've had many failed experiments in loading data before we found something that worked well enough for our needs. So we tried some transactional Gremlin. We had transactional Neo4j, and that was working fine. But unfortunately, in Neptune, it just wasn't performance. This might work better in other data stores, so other Gremlin stores. If you want to try it, maybe these lessons will be helpful. One, basically to pull up vertices on the graph in Neptune, you often do g.v, but this, doing it multiple times doesn't perform well. We would, basically our good paradigm for this was to look up two vertex IDs. To create a link was better to look up the IDs separately versus trying to do g.v.has, .g.v or .v.has again. So basically looking up IDs separately is helpful. Smaller traversals are generally better. You can have mega traversals that are super long, but it tend to take a lot longer than multiple small traversals. And there's a thing called coalesce, which is basically you get the first of multiple traversals that actually return something. It's one paradigm is look for an existing node or create a new one. And doing this on the right side can be very slow in Neptune, unfortunately. A few other failed experiments on the AWS side. We have the sessions client, which AWS Neptune offered. It was still kind of slow. We still ended up with some timeouts, concurrency issues. It helped a little, but not enough. And we also tried using a Kinesis stream and using AWS Lambda to write to AWS Neptune. It was better, but bulk loader still gave us a 5 times throughput. We still saw some concurrency exceptions even when doing one write per vertex and edge, which is kind of perplexing. So Neptune, we went with the bulk loader because it gave us the best performance and fewest weirdness. As far as the upstreaming plan, We spent a long time stabilizing and making our Gremlin code performant. Now we're doing some internal refactoring to consolidate our shared Gremlin code into like an Amundsen Gremlin repository. And then we'll use the existing, like the shared code from the metadata service and data builder. And then, of course, we'll actually ship these to Amundsen, and along with the like proxy tests that are used by the Neptune side. So I'm the only one presenting because I'm recording the upstream work, but like by no means did I do this on my own. This is a huge team effort from the Privacy and Entertainment Square, especially Dan Sims and Alyssa Ransbury, Sarah Harvey, and Kat Hawthorne. Okay, any quick questions? I linked the Amundsen issue related to like supporting Gremlin, but happy to field any quick questions if I can. If people are curious more about things. Exactly. Yeah. So initially we did use Neo4j. We were using the community Neo4j for a little while, which fortunately the migration was fairly. So the migration itself of data was pretty straightforward, right? Because we just have data builder throwing in data, so we could just like we hadn't launched in production yet, so we just kind of dropped everything and reloaded everything. So that part was straightforward once we got the proxy working. Which was the bulk of the work, unfortunately.
Thanks. Other questions for Joshua? Alyssa says there are also instructions in the GitHub issue for how to migrate data without dropping everything. All right. Thank you, Joshua. I appreciate you taking the time to present. If you have more questions for Joshua, please message him on Slack.
That's good. Thanks.
And with that, we can wrap up the call for today. Thank you all for coming. Josh, Shanshan, Carter, Tao for presenting. And we're always looking for more presentations. So if you have topics you want to present next time, please do post on Slack. Thanks again.
Wait a second.
Yeah, please.
We have yeah. Hey everyone. So what we'll be doing in the Slack channel, we created a front end specific channel. We thought it would be good to have a separate channel to start having some more of these conversations. And so what I've done recently to help with knowledge share internally with all the new members that recently joined the team, as well as for the sake of growing the community, I had created some slides that just gives a quick overview. And since the community is pretty heavily data or backend focused, and then those slides also will give I guess a quick discussion of some of the challenges that we're facing as well as potential solutions. This in itself should be a presentation, and we'll probably present about it at the next meeting. But we just wanted to get the ball rolling with that channel, and I'll be posting those slides in that channel so that we can start having some of those discussions for anyone who's interested. All right. That's great. Thank you so much, Tamika, and look forward to the next presentation then.
Yeah, I listened to that. It's very great. Thanks.
Cool. Anything else from anybody? All right, then. Thank you, everybody.
Thank
Take
you.
care.
See
Bye.
you.